2.3 rates of change. We're going to talk about the average rate of change. Number one, average rate of change. Definition. So the average rate of change is equal to the change of y with respect to x in the interval from a to b. So that is f of b minus f of a over b minus a, or delta x over delta y. So it looks like a slope, rise over run, difference in y over difference in x. So that's delta y over delta x. So here's a picture. We have a function f of x. We have a point here a, f of a, and another point b, f of b. So the secant line that connects these two, we call it the secant line, has the following slope. So we can see here the vertical change is f of b minus f of a, and the horizontal change is b minus a. So that is exactly the slope rise over run, which we call average rate of change. So example 1, this example is from medicine. The concentration C in milligrams per milliliter of a drug in a patient's bloodstream. So the concentration C of a drug in a patient's bloodstream is monitored. Let's just say is given in the following table. In other words, it's monitored, it's recorded every 10 minutes for an interval of 2 hours. So I'm just going to give some of those values. So we have T in terms of minutes and concentration. So 0 times 0 concentration. First 10 minutes, it's 2. Then 20 is 17. 30 is 37. 40 is 55. And 50 is 73, and so on. Let's just use this information, and now we have to find the average rate of change. Find the average rate of change of C over the following intervals. So first, over the interval from 0 to 10, or in the first 10 minutes. So delta C, that's the average rate of change for the concentration, is equal to the difference in C. So we're looking here what we have from 0 to 10. So we're going to look at this and this. And so we have 2 minus 0 for the C, and the difference in T is 10 minus 0. So 2 over 10, 1/5, or 0.2 milligrams per milliliter per minute. So that is the rate of change. B, if the interval is from 0 to 20, then the average rate of change for the concentration will be different. So we're looking for 20 is 17 minus 0 over 20 minus 0. 17 over 20, which is 0.85, and so on. Another application for average rate of change is the average velocity. So we know the average velocity is equal to change in distance over change in time. This is the familiar formula that rate is equal to distance over time, but we talk about a change in distance, change in time. So example 2, a free-falling object is dropped from a height of 100 feet. So a free-falling object is dropped from a height of 100 feet. The height S is a function of t in feet. Is given by this equation. S of t equals negative 16 t squared plus 100. So if we ignore air resistance, this is the equation that describes the height of the falling object. So we need to find the average velocity of the object over the interval. Find the average velocity of the object over the interval 1 to 2. So we don't have a table here, but we have an equation. So by definition, the average velocity, which is delta S over delta T, is equal to, we look at the interval from 1 to 2, so S of 2, difference in distance, the change in distance, minus S of 1, over 2 minus 1. So we need to calculate S of 2 from the equation, and we substitute 2 for T, and we find out this is negative 64 plus 100, or 36. And then we have to calculate S of 1, negative 16 plus 100, 84. So now we substitute in the equation, and we have 36 minus 84 over 1, which is negative 48 feet per second. So this is the average velocity of the object. Number 2. So far we talked about rate of change or average rate of change. Now we're going to talk about instantaneous rate of change. Instantaneous rate of change. And of course velocity. So by definition, the instantaneous rate of change of y equals f of x is the limit of the average rate of change on the interval from x to x plus delta x. We used to have a to b, now it's from x plus delta x. The difference between the 2 points is delta x, as delta x approaches 0. So let's write this down with an equation. The limit of the average rate of change when delta x goes to 0, which is also the difference in the y coordinates f of x plus delta x minus f of x over delta x when delta x goes to 0. So think about the average rate of change being the secant line and the instantaneous rate of change being the tangent line. So the tangent line is the limit, or the slope of the tangent line is the limit of the slope of the secant line. So make a note, if y is distance, if y is distance function, and x is time, so we have distance over time, we call this rate of change velocity. The rate of change is velocity. So in other words, the instantaneous rate of change is also called velocity. So example, finding the instantaneous rate of change. Find the velocity of the object. That's the instantaneous rate of change of the object in example 2 at t equals 1. So if average rate of change is over an interval, the instantaneous rate of change, or the velocity, is at a point. Okay, so a function from previous example was negative 16t squared plus 100. This is our position function. This function describes the position of the object at any moment. The derivative of that function, according to the formulas we have, the rules for differentiation is negative 16 times 2t, which is negative 32t. So the derivative is the instantaneous rate of change, or the velocity, as a function. Now we're going to evaluate this derivative at t equals 1, and we have negative 32 times 1, which is negative 32 feet per second. So this is the instantaneous velocity of the object at the moment t equals 1. And this concludes the lecture.